Hey everybody, so in this video we're going to talk about section 8.3. We're just going to talk about the first part, which is going to cover simplifying rational expressions and multiplying and dividing rational expressions. Okay, so just a reminder, okay, all of this stuff should really be review for you guys. You should know how to simplify rational expressions, okay, but the first step is to factor both the numerator and the denominator. Okay, and then the second step is to cancel any common factors. Okay, so we'll just do a couple examples of this. To remind you of how it works. Okay, so now if you look at this example, you can see that the denominator is already written in factored form. So I'm going to go ahead and factor the numerator. Okay, so I'm actually going to reorder the terms first so that they're in the right order. Okay, and then because I have the leading term as a negative, I'm going to factor out -6. So I'll have -6 times y squared minus 1 over y minus 1 squared. Okay. And now I can see that this is the difference of squares, so I'm going to continue factoring this. So I have -6 times y plus 1, y minus 1 over y minus 1 squared. Okay, now you can see I do have this common factor of y minus 1, so I'm going to have the y minus 1 from the numerator cancel one of the y minus 1 terms from the denominator. Okay, and this leaves me with -6 times y plus 1 over y minus 1. Okay. Now you can't force these to be the same and cancel them because the first term is the same and the second term is opposite. Okay, so that is as simplified as we can get. Okay. Okay, now if we look at the numerator, again, we have these terms that are not in descending order, so we're going to write the terms in descending order. Okay, and then in the numerator, we can see that they both have a factor of 2, and because the leading term is negative, I'm going to factor out -2. Okay, and in the denominator, I have the difference of cubes. So I'm going to use the difference of cubes formula that we had when we talked about factoring earlier. So I get x minus 3 times x squared plus 3x plus 9. Okay. Now I can see my common factor of x minus 3. So I'll cancel this x minus 3 with this one. Okay. And I get -2 over x squared plus 3x plus 9. Okay, and that's my final answer. Okay. All right, so that's the examples that I wanted to talk about in terms of simplifying. So you guys are going to see a lot of that factoring out of a negative in the examples that you have on the homework. Okay. Now let's talk about multiplication. Okay. So for multiplication, the first thing you want to do, again, is factor everything. Okay, so I mean all numerators and denominators. Okay. Then you want to, now these two can kind of be in any order. Okay. You can either cancel common factors and then multiply straight across. Okay, or you can do them in the other order where you multiply straight across and then you cancel the common factors. It really doesn't matter what order you do those two in. Okay, so let's look at an example. Okay, so I'm going to go ahead and factor everything here. So in the numerator of the first term, I have a difference of squares. So this is going to factor as 2x plus 1 times 2x minus 1. Okay, I also have a difference of squares in the denominator. So this is going to be x plus 4, x minus 4. Okay. Now, when I factor my second term, these have a common factor of x. So I'm factoring out x, and I have x minus 4. Okay, the denominator doesn't have any common factors, so we're just going to assume that this is already factored. Okay, now we're looking for factors that appear both in the numerator and the denominator. So if you look, you have 2x plus 1 canceling with this 2x plus 1. Okay, and we have x minus 4 canceling with this x minus 4. Okay. So what's left over in the numerator? We have x and 2x minus 1. Okay, and in the denominator, because both of these are canceled, all we have is x plus 4. Okay. Now, you can multiply this out if you want to, but I'm not really looking for that. So on the quiz and on the test, to save time, I encourage you guys to leave your answer in the factored form here. Okay. Let's look at another example of this. Okay, so we're going to factor everything here. So in the numerator, I'm going to have what multiplies to -3 and adds to +2. So that should be +3 and -1. Okay, and then in the denominator here, I'm looking for something that multiplies to 2 and adds to 3. So that's going to be 2 and 1. Okay. Then here I have a common factor of x. This is something that oftentimes students aren't thinking about this type of factoring, but you can always factor out the greatest common factor. So we're going to factor out x here. That leaves me with x plus 2. And in the denominator, I have the difference of squares factoring. So I have x plus 1, x minus 1. Okay, and now we're going to look for common factors. So in the numerator, I have x minus 1. Here's my x minus 1 in the denominator. Those are going to cancel. Okay. I have x plus 2 in the numerator canceling with this x plus 2 in the denominator. Okay, and remember, you cannot cancel these two because they're both in the denominator, right? X minus 1 over x minus 1 cancels. X plus 1 times x plus 1 does not cancel. Okay, so this would leave me with x times x plus 3. And then in the denominator, what's left is x plus 1 times x plus 1. Okay, again, I'm going to encourage you to leave this in the factored form, but a lot of students prefer the form where you have x times x plus 3 in the numerator and then x plus 1 squared in the denominator. And that is also considered factored form. So either one of these is totally okay. And this obviously isn't taking a lot of time. That's my main objection to students multiplying this all out, is you have a limited time to take the test. You want to make sure you're using that time effectively. Okay. All right. So there are some examples for multiplying. Okay. So let's talk about division. Okay, so I'll just remind you of the plan. The first step is to change to multiplying by the reciprocal. Okay, now it's very important that you do this step first. What happens when students start factoring first and then changing to the reciprocal is they end up canceling things out that you don't really get to cancel when you change to the reciprocal. Okay, so it's important that you do this step first. Then the second thing you're going to do is factor. Okay, again, you're factoring all numerators and denominators. Okay. And then the last thing you're going to do, oh, I'm sorry, you're going to cancel common factors. Okay, and then the last thing you would do is multiply straight across. Okay, so it is very similar to the process for multiplication. We just have this extra step at the beginning that really differentiates it. Okay, so let's look at an example of this. Okay, so again, the first thing we're going to do is change to multiplication by the reciprocal. So this term stays the same. And we're changing to multiplication by the reciprocal here. Okay, and now we're doing the same process that we did in the previous example about multiplication. So we're going to factor. Okay, so this is going to be 2x and x. Okay, and then we're looking for things that multiply to 6. Okay, so we're thinking 2 and 3 probably. Okay, so let's check. Minus 4 plus 3, that is minus 1. Okay, factor here, 3x and x. Okay, now the only things that multiply to 1 are 1 and 1. And then we'll just double check. So 3x plus 1x is 4x. Okay. Okay, again, here we're having 3x and x. Okay, if we want this to add to 7x, we're going to put the 2 here and our 1 here. 6 plus 1 is 7. And in the denominator, we have 2x and x. Okay. And we're looking for something that's going to multiply to 6. So we're thinking 2 and 3. We'll probably put the 3 here and the 2 here. And we want positives. So this is going to be 4 plus 3 is 7. Okay, so now we're going to cancel all of our common factors. So we have 2x plus 3 canceling with this 2x plus 3. We have 3x plus 1 canceling with this 3x plus 1. And we have these x plus 2's canceling. Okay, so the only thing left is x minus 2 over x plus 1. Okay. All right, let's look at another example with division. Okay, so I wanted to remind you that when you have something like this that doesn't have a denominator, just like 4 is the same as 4 over 1, this, which is the analogous of a whole number, you can always put this over 1. Okay, so now we're going to change to multiplication by the reciprocal. Okay, and now we're going to factor everything. So here we're looking for something that multiplies to positive 4 and adds to negative 5, so it should be negative 4 and negative 1. Okay, denominator is just 1, so obviously that's already factored. X squared is already factored. And in the denominator here we have a difference of squares, so this is going to be x plus 1, x minus 1. Okay. Now we're looking for common factors. It looks like the only common factor is x minus 1. Okay, so in the numerator, we're going to have x squared and x minus 4. And in the denominator, we're going to have x plus 1. Okay. All right, so remembering this trick where you can put the polynomial, which is like a whole number, over 1, is what will help you do these types of problems. We're actually going to do another one that's kind of like that. Okay, so again, we know that when we have something that doesn't have a denominator, we can always put it over 1. Okay, so then when we change to multiplying by the reciprocal, this is going to change to multiplying by 1 over 3x. Okay, we're still going to factor everything. So the numerator here has a common factor of x, so we'll have x times x plus 3. Okay, 2y is already in factored form, and the 3x is already in factored form. So when we're looking to cancel here, we have x in the numerator and x in the denominator, and that's really all you can cancel. So what's left in the numerator is x plus 3, and what's left in the denominator is 3 times 2y, or 6y. Okay. I want to point out at this point in the example that you can't cancel this 3 with the 6 unless you're splitting this up like we saw in the section about polynomial long division. So if you were to split this up, you could certainly write this as x over 6y, okay, plus 3 over 6y, and then you can cancel them. Okay, but in general, because this is a single term, we think that this is more simplified than this. Okay, so you want to leave your answer like this rather than splitting it up. But I also wanted to point out that you can't just cancel this because the x is not divisible by 3. So you would have to have both terms in the numerator being divisible by 3 for that to cancel. Okay. So that's all there is for this review of simplifying, multiplying, and dividing. And in the next video, we'll talk about adding and subtracting. I will see you guys soon.